So unit 4, lesson 8, is on the binomial theorem. Now, the binomial theorem is a way to expand binomials that are raised to a power. So if I have x plus 2 and then raise that whole thing to the third power, that's when I would use the binomial theorem. Now normally what we do is they'd FOIL that out. So we'd have to multiply by x times 2 times x times 2, and then FOIL that, get an answer, and then multiply that by x times 2. Now that's not usually too hard if it's just like something to the third power. But if we go something to the 7th or 8th or 9th power, that could be quite a lot of work, and we want to find a shortcut that does that for us. And that's what the binomial theorem is. So we're going to start doing that now. We're going to start with something that doesn't seem like it has anything to do with it. So we're starting with Pascal's triangle. Now Pascal's triangle is a mathematical triangle. It's full of numbers. The first 3 numbers are 1, and they're written like that, 1 with 2 ones underneath of it. Now each row in Pascal's triangle has one more number than the row above it. So the third row is going to have 3 numbers, and the fourth row will have 4 numbers. So after we look at this, we have 1, 1, and 1. The numbers on the outside are always 1, so we'll start with that one. Then inside the triangle, though, it becomes more interesting. The number on the next row is the sum of the numbers that are above it diagonally. So since the next number is going to be between those 2 ones, we add those ones and we get 2, and that's where we get the 2. And then since there's only 3 numbers, the last number is the outside again, and it's a 1. So in the next row, we start with a 1, and then we add the 1 and the 2 that are above the next number, and we get 3. We add the 2 and the 1 that are above that number, and we get 3, and we have a 1 on the outside. So then we do 1 plus, then we have a 1 on the outside again. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then another 1 on the outside. Then we go to the next row again, so we have 1, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, and 4 plus 1 is 5, and then a 1 on the outside. And this pattern is just going to continue and repeat as far as you want to make the triangle. Now as far as the homework goes, you're going to need to go up till you have up to a 9. So here we have up to 5, you're going to have to go up to 9. But why do we need Pascal's triangle? Well, Pascal's triangle is numbered thus like this. The first row is row 0, the next row is row 1, then row 2, row 3, row 4, and row 5. It's easy to remember the row numbers because the second number in the row is the row number. So you see 1, 2, 3, 4, 5. And those are going to give us the coefficients that go for that power in the binomial theorem. So to bring that into what we're doing, if we want to expand a plus b to the nth power, we know we're going to have n plus 1 terms, which means we're going to have whatever the power is, it's how many plus signs you're going to have. So we don't know how many it is, so that's why I had the dot, dot, dot in the middle. Now the first part of each term is going to have a number from the Pascal's triangle, something from the first number in the term in the binomial, and something from the last term in the binomial. So first you put in the coefficients for Pascal's triangle from row n. Now we don't know what that is, so I just use C to represent the coefficients. Then we're going to put in our a's. So we're all going to have something with a. We're going to start with the highest power, and then go down until we have a to the 0 power. Then I'm going to start with the b, which is the second term, and I'm going to have b to the 0 power. And instead of counting down, I'm going to count up. So I start with 0, and I go up to n. So if you do this right, all of the exponents should add to that n. And let's see how that works with real numbers. So I'm going to do x plus 2 to the 4th power. So I'm going to have n plus 1 terms, which is going to have 4 plus signs. So I spread them out. The first thing I put before each plus sign is number from Pascal's triangle from row 4, which was 1, 4, 6, 4, 1. Okay, then I look at the first term, the x. I start with x to the 4th, and I descend. X to the 3rd, x squared, x to the 1st, and then x to the 0 power. Then I do the same thing with 2, only instead of starting with 4 and going down to 0, I start with 0 and go up to 4. So 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, and 2 to the 4th. Now, I'm finished with the Pascal's triangle part. What I'm going to do now is combine everything and make it look neat, so it looks like standard form. So first I do 2 to the 0 power, 2 to the 1 power. Those are all values. They have numbers. 2 to the 0 power is 1. So 2 to the 0 becomes 1, so it's 1x to the 4th. 2 to the 1st is 2, so we have 4x to the 3rd times 2. 2 squared is 4, so we have 6x squared times 4. 2 to the 3rd is 8, because 2 times 2 is 4, times 2 is 8. So we have 4x to the first 8 times 8, plus 1x0, and then 16. 2 to the fourth is 16, because 8 times 2 is 16. Now we multiply the 2 times that coefficient that's in front. We can do that because they're both numbers. So I can change that now and write x to the fourth plus 8x to the third plus 24x squared plus 32x, because x to the 1 power is just x, plus 16, because x to the 0 power is 1. So 1 times 1 times 16 is 16. And that's how I expand x to plus 2 to the 4th power with binomial theorem. Now that's the only thing we have to do. I have 8 problems like that in the homework. So why don't you go ahead and get started, and good luck on that, and I'll see you next class.